So once you're super duper experts at doing regular roadmap questions, we can add a couple of tweaks to them. And the first one is getting the percent yield. Okay, the percent yield is where you divide what you made, so look at that made, blah, 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 over what you could have made, which is what you get using the roadmap, and multiply it by 100. So let's look at what we're dealing with here. We used 9.5 grams of this. Okay, we made this. Right now we don't care about the fact we made 3.39 grams because that's what we actually made. What we want to calculate first is how much could we have made. Okay, so anytime you're doing a percent yield calculation, you need the theoretical yield, and unless they give you the theoretical yield straight out, then you need to calculate it with a roadmap process. Not going to dwell too much on this other than just make sure I'm using the right numbers because we've done so many of them. We start off with this benzaldehyde and we end up making benzyl alcohol. Step 1, grams of benzaldehyde, 9.5 grams, 2 moles of benzaldehyde, divide by 106 and we get 0.0896 moles of this. That goes in this box here, remember. Step 2, convert from moles of the pink stuff to moles of the brown stuff. It is a 2-to-1 reaction, so the coefficient of B is 1, the coefficient of A is 2, so therefore the moles of B, the moles of benzyl alcohol here, 0.0448 moles. Step 3, convert that to grams, where we've done a million times. So that's 4.84 grams of this C6H5CH2OH. And that is the theoretical yield. Okay, you can calculate the theoretical yield using the roadmap. Now we say, but we actually made 3.39 grams, calculate the percent yield. So percent yield is what you got, 3.39, over what you could have got, 4.84. which is 70%. We'll do a few more of those. So student told could prepare chloroethane by mixing ethane with chlorine, added 2 grams of ethane, so that's what we're starting off with, could then use a university lab, blah, 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 found that he made 1 gram of chloroethane. Had made 1 gram, that is the actual yield. First of all, we need to calculate the theoretical yield, knowing that we started with 2 grams of ethane. So appropriate colouring, throw in the roadmap. So we're starting with ethane, we're making the chloroethane, and we need to know how many grams of chloroethane we could have made. So step 1, grams, 2 moles, so 0.0667 moles of the ethane. That will goes in this box. Convert that to moles of the chloroethane. Well, to do that, we need the coefficient of the equation. What equation, you say? Well, the equation that we're told, ethane plus chlorine makes chloroethane, plus of course the HCl. 1-to-1 reaction, so therefore the moles of chloroethane, 0.0667 moles, convert that to grams, giving us 4.3 grams possible. Okay, so that's the theoretical yield. This was the actual yield, percent yield, actual over theoretical, the 1 over 4.3, or 23.3%. So Beth then prepared some ethoxyethane, S-ethoxyethane, by reacting ethanol with conch sulfuric acid. The conch sulfuric acid is, of course, just effectively a catalyst, so we don't include it in the equation. Already color-coded it for you. 69 grams of ethanol was used and obtained 45% of ethoxyethane. Calculate the mass of ethoxyethane made in grams. Well, this is kind of a fun one. Right, first of all, let's see what we got. We know that the ethanol is what we know all about, and ethoxyethane is one way or another what we're interested in. So let's use the roadmap to get the theoretical yield of ethoxyethane. So step 1, moles of ethanol is going to be the 69 grams divided by 46, which is 1.5 moles of ethanol. The equation is a 1-to-2 reaction, so therefore the moles of the ethoxyethane with coefficient of 1 over the moles of ethanol that we just calculated as 1.5, coefficient of the ethanol of 2. So therefore that gives us 0.75 moles of the ethoxyethane, which weighs 55.5 grams. Okay, so could have made 55.5 grams. In this case, we're told the percent yield is 45%. So therefore the 45% goes there. Theoretical, we just calculated 55.5 grams. And what's left in this equation is the actual yield, which is what the question asking for. Calculate how much Bethan actually made in grams. Multiply that through, and she made 25 grams. Now, a little question, benzene, 10 grams of benzene, make benzoic acid, that's benzoic acid, got 3.8 grams of benzoic acid, that is the actual yield, calculate the percent yield, got to use the roadmap. So start with benzene that we know of, 10 grams, interested in benzoic acid that we don't know about, but we would dearly, dearly love to know about. And so step 1, 10 grams of benzene is equal to 0.128 moles of benzene. That's in this box. Moles of benzene to benzoic acid. What we can tell from the equation, it's a 1-to-1 reaction. So just pop that in and we get 0.128 moles of the benzoic acid, which we then convert to grams. So we could have made, or student could have made, 15.6 grams. Student actually made 3.8 grams. So the percent yield, the 3.8 actually made over the 15.6 could have been made, which is 24.4%. Considerable interest in green methods for production of organic compounds. Recent studies have shown that ester BA, shown below, can be produced from 2-amino benzoic acid and butanol at 37 degrees Celsius. Well, let's quickly, before we go any further, 2-amino benzoic acid is that, and there's butanol, and so that's the reaction that we're looking at. Okay, in a small-scale experiment, 4 times 10 to minus 4 moles of 2-amino benzoic acid gave a 5% yield of BA. Calculate the number of moles of BA that were produced. Now, this is a fun one because it's a percent yield in which we're just doing moles. Okay, most of the time you see percent yield is in grams. You figure out the theoretical yield in grams and then get the actual yield in grams, but absolutely no problem at all working in moles. So 5% was our percent yield. The actual yield in moles, which is what we're asking for, divided by, well, if we had 4 times 10 to the minus 4 moles of this, and it's a 1-to-1 reaction, we would expect 4 times 10 to the minus 4 moles of BA. Rearrange, actual number of moles, 2 times 10 to the minus 5. So propanone reacts with hydrogen cyanide. There's propanone reacting with hydrogen cyanide to make the 2-hydroxy-2-methyl propane nitrile. Nice question that we have done other parts of in other worksheets. An experiment excess of hydrogen cyanide reacted with 17.4 grams of propanone. So we know that. That's what we're going to be using for our theoretical yield. And it made 18.6 grams. Don't care yet because that's the actual yield of our 2-hydroxy-2-methyl propane nitrile, this stuff. So usual thingy. There we are, molar mass of propanone, 58.06, molar mass of our product, which I'm just calling product rather than typing all that out because it would make it horribly big, 85.07 grams per mole. Step 1, get the moles of the propanone, which is 0.3 moles. Step number 2, where's the reaction? It is a 1-to-1 reaction. So therefore, the moles of the product is 0.3 moles, which we can then convert to grams by multiplying by the molar mass, 25.5 grams. We want the percent yield. We're told our actual yield is 18.6 grams. So the percent yield actual over theoretical, 18.6 over 25.5 times 100, which is 72.9%. So CFCs are replaced by hydrofluorocarbons, HFCs, such as difluoromethane, which can be made by the reaction of dichloromethane with hydrogen fluoride in the presence of catalyst. Write a statement that links the mole ratio of HF to that of CH2Cl2 with the yield of difluoromethane. Well, obviously, the more HF you have, the more product. although that's only going to be true once you get up to a ratio of 2 to 1, because once you're past a ratio of 2 to 1, the HF is simply in excess. Experiment using 0.4 moles of CH2Cl2. The yield of CH2F2 was 89%. Calculate the mass in grams of the difluoromethane produced. Well, 89%. That was our percent yield. It's the actual yield over 0.04 moles. So this will give us the actual yield in moles, of course, which is 0.0356 moles CH2F2, just like the last question, except now they want the mass of that. Well, that's easy. Just multiply it by the molar mass to get 1.85 grams of CH2F2. So chloroethanoic acid produced from ethanoic acid with chlorine under suitable conditions, which then reacts with ammonia to produce aminoethanoic acid. And that's the overall process, ignoring the other reagents and so forth. In an experiment, 89 grams of ethanoic acid right there, then gave 49.2 grams of aminoethanoic acid. Calculate percent yield of aminoethanoic acid. So we don't care about this middle one. We're starting there and ending there. So roadmap. To emphasize, starting with ethanoic acid, the 89 grams of that. The theoretical yield we're interested in is that of the aminoethanoic acid right there. So our usual step 1 converts 89 grams to moles, and we get 1.48 moles. Next step, going from moles of ethanoic acid to moles of aminoethanoic acid, and it's a 1-to-1 reaction. So moles of aminoethanoic acid, 1.48 moles. And then, of course, calculating the theoretical yield in grams, 1.48 moles multiplied by 75 grams per mole is 111.3 grams. So that's the theoretical yield. Percent yield is the actual yield, which is 49.2 over the theoretical, 111.3 times 100, giving us 44.2%. 2-hydroxy-5-nitrobenzene carboxylic acid, right there, made by reacting 2-hydroxybenzene carboxylic acid and aqueous nitric acid. In this experiment, percent yield of the dry 2-hydroxy-5-nitrobenzoic acid was 41%. Calculate the mass produced based on the original mass of the 2-hydroxybenzene carboxylic acid here, which was 4 grams. So, roadmap, squished down a bit because we had a pretty picture to put in there. Start off with the reactant, which is the one in pink, 2-hydroxybenzene carboxylic acid. There we are, started with 4 grams of that, and they're nice enough to tell us the molar mass is 138. And we're interested in this product here, the 2-hydroxy-5-nitrobenzene carboxylic acid. And they tell us the molar mass of that is 183 grams per mole. So usual, step 1, turn that 4 grams into moles. And we have 0.0290 moles of the reactant. Step number 2, how many moles of the product will that be? Well, again, it is a 1-to-1 reaction, as much organic chemistry is. So 0.029 moles of the product here, which we turn to grams, 5.3 grams. So expect 5.3 grams. We had a 41% yield, which will help us to determine the actual yield. So the usual percent yield, actual over theoretical, percent yield was 41. Theoretical yield, 5.3 grams. Munch all that up. And the actual yield, 2.17 grams. So the last question, one that I was expecting an awful lot more of, and that is where we have to do a limiting reactant determination first. So we got the equation reaction between ethanoic acid and methanol. It tells us we have 3 grams of ethanoic acid and 1.28 grams of methanol. So we've got 2 reactants here. Just by looking at it, we can't tell which is the limiting reactant. So we actually have to apply the roadmap twice before we can calculate the percent yield, because we need to know the theoretical yield based upon the limiting reactant. So anyway, start off with substance A being ethanoic acid, substance B, which will be the case in both calculations, being the ethyl ethanoate, So we got 3 grams of the ethanoic acid, divide it by 60 to get 0.05 moles of ethanoic acid. It's a 1-to-1 reaction, so we're going to have 0.05 moles of the ethyl ethanoate. And then I kind of am almost potentially wasting a little step here, but I want to make sure that we take everything through nicely to emphasize things. So I will go ahead with step 3 and determine that that is enough ethanoic acid to make 3.7 grams of the ethyl ethanoate. Okay, now that's not necessarily, however, the theoretical yield, because it might be that 1.28 grams of methanol is the limiting reactant. So 3 grams of ethanoate was enough to give us 3.7 grams of the methyl ethanoate. I've been calling it ethyl. It is, of course, methyl ethanoate. But now we need to do an identical calculation, but instead of having ethanoic acid as substance A, we now consider methanol as substance A. So 1.28 grams of methanol, again, whizzing through it. Step 1, convert grams of methanol to moles of methanol, 0.04 moles there. It is a 1-to-1 reaction, which means that 0.04 moles of methanol will give us 0.04 moles of a methyl ethanoate, which we then convert to grams, 2.96 grams. Now at this stage we say, well, which one of these is the limiting reactant? Which is the one that determines the theoretical yield? And the answer is, of course, that the 3 grams of ethanoic acid was enough to give us 3.7 grams of the methyl ethanoate, whereas the methanol was only enough to give us 2.96 grams of the methyl ethanoate. Thus, the methanol is the limiting reactant. So now we'll go ahead, calculate the percent yield. We made 1.18 grams of methyl ethanoate. Theoretically, we could have got 2.96 grams of methyl ethanoate. Thus, the percent yield, 39.9%.